Hey everybody, here is a third example, solving trig equations and dealing with quadratic form and identities. So the directions read as follows. Solve the following trigonometric equation in the interval from 0 to 2 pi, where 0 is included and 2 pi is not included. That's the meaning of the bracket in parentheses, interval notation. Hint, square and convert to quadratic type. Hints won't always be given to you. You are taking advantage of the fact that they are right now. So let's look at this. We only have one equation, but we have two trigonometric functions mentioned in here. If you have two different trig equations, it's almost like you want to think of it as a system of equations. We want to substitute something in so that we could get it into just one trig equation. From here, what we'll do is, as the hint states, we're going to square and convert to a quadratic type. If I square both sides of the equation, whatever you do to one side, you have to do to the other. The right side's the easy part. Cosine of theta quantity squared, well, that's just cosine squared theta. The left side is trickier because people try to be a little too confident and they just distribute the square and like give it to each thing, and no one ever taught you that, okay? When you have a sum or a difference, you cannot do that. You are allowed to do that when it's only multiplication and or division inside of that parenthesis, when it's one big expression together, but this is the sum of two expressions. You cannot square each piece and call it a day. When it's squared, it's so nice, we write it twice. So sine theta plus 1, sine theta plus 1. Now we're going to distribute or use FOIL, the mnemonic device FOIL, to help us multiply and expand all of this. Sine times sine will give us sine squared theta. Outer and inner are both sine theta. Sine theta plus sine theta is not sine squared theta. That's from multiplication. When you add, we have plus 2 sine theta, and then last times last is 1. Be careful that you don't do 1 times 1 is 2, which is a common weird little mistake. Now, if you just watched the video I recorded right before this, which was with tangent in it, secant squared and tangent squared were in it, I mentioned that you won't always have where all of the trig functions are squared in the example. They could be to the first power. And here is a perfect example of that. So I know I want to do what I did in that last example. I want to use a Pythagorean identity so I could get rid of either sine or cosine and then have my equation be only one trig function. How will I decide? The Pythagorean identity that I'm going to use to substitute is sine squared theta plus cosine squared theta equals 1. Sorry. I have a sine theta to the first power, and I can't really do anything about that. That's going to have to stay. Since that has to stay, I'm going to keep sine squared, and I'm going to get rid of cosine squared. If I isolate cosine squared theta over here using my Pythagorean identity, and again, you should be able to kind of do this in your head at this point, especially because we've practiced the identities quite a bit. But if not, I'm just showing you a little side work. Cosine squared theta, based on the identity, is equivalent to 1 minus sine squared theta. This we know as fact, so since we applied all legal algebra, this is also exact. It's true, it's a fact, that's it. Plugging that right over here, sine squared theta plus, plus 2 sine theta plus 1 equals 1 minus sine squared theta. This sine squared theta and this sine squared theta, be careful that your 2's don't get too big and look like a coefficient on theta. That was not really written well because double angles are in our near future. We have, these don't cancel out because they are on opposite sides of the equal sign, even though one's positive and negative. We need to get this equal to 0 in order to factor and use quadratic processes, and in order to factor and use zero product property. So I'm going to add sine squared theta to both sides. And I'm also going to subtract a 1 from both sides. Those cancel. Cancel gives us 0. These, I get 2 sine squared theta plus 2 sine theta. These actually cancel out, and that's all I get. So I don't have a quadratic trinomial this time. This time I have a quadratic, well, trig quadratic, but it is more of the style of a quadratic binomial. And quadratic binomials could really be in two forms. They're either ax squared plus bx, or they're ax squared plus c. Obviously the plus is a stand-in, as b, a, b, or c really could be negative, okay? In the case that you have this, if it were a minus, you might look for a difference of 2 squares. Here, we're definitely going to, at the very least, have a GCF because they at least have x in common, if not more than x. So we're going to factor using greatest common factor. They do have a 2 in common, but they also have sine theta in common. That's the greatest common factor. So I'm going to factor that out front. I'm going to underline it since I show it this way when I do grouping. I'm going to do the grouping style method, but only on 2 terms instead of 2 groups of 2, you know? Then 2 sine theta. Am I going to be squished? There we go. Got to watch for that. 2 sine theta out front. That's this guy coming out front. And if I reduce pretzel style, again, if you don't get that, please watch some factoring lesson videos. I'll try to remember to link them below if you need more help. Reduce pretzel style, and we're left with sine theta plus, try it yourself. Don't let me just do it and you blindly copy. Hit pause if you need, whatever. Plus what? That's going to be a 1. Now we are using zero product property just like any other factoring question. This 2 sine theta over here is more like 2 sine theta plus 0. This often helps people. I'm just going to put a star and go over here. If you think of it as 2 sine theta plus 0, sine theta plus 1 equals 0. Sorry, I'm squeezing over there. That is essentially what's happening, okay? So just going to go over here so I don't have to be so squished. And that was just our Pythagorean identity side work. Right. Carrying on from here, zero product property. I don't need to write the plus 0. That's why we don't. 2 sine theta equals 0. Sine theta plus 1 equals 0. Divide by 2. 0 divided by 2 is 0. And subtract 1. Sine theta equals -1. Then you just have to ask yourself the right question. The sine of what angle is 0, or angles are 0, between 0 and 2 pi. Sine is the y value. You will not have a unit circle in front of you to do this. Where is the y value 0? This is the x-axis. The x-axis is where y equals 0. Anything above it, y is positive, and anything below it, y is negative. So which angles are we going to use? 0 and pi. We don't include 2 pi in this answer because the answer or the directions show the interval goes from 0 with 0 included, but doesn't include 2 pi. It just doesn't want to be redundant and repeat the same place, okay? So we have 0 and pi for this part. Where is the y value? -1. What angle or angles, in this case, there's just one answer, does the y value equal -1 when theta equals? Any ideas? It's going to be down here. That's when it's -1. Here's where it's +1. -1, +1. Okay? That would be 3 pi over 2. So we have 3 different answers for this question right here. I will color coordinate it a bit like I did for the other examples. And now we've kind of had a little bit of a sampler, a lot of different scenarios of what may or may not happen when you're solving a trig equation that has quadratic terms in it, where you have your trig to the 2nd power. you would apply any relevant algebra process to a trig equation. Just make sure that you are following the rules as they apply to algebra and applying them to trigonometry. Make sure you're reading all of the directions and make sure you consider your Pythagorean identities on these, okay? So again, I hope this helps you understand what to do. I hope that this really resonates and sticks with you and you aren't that person who just squares each thing and calls it a day, because I promise it's not a shortcut. It's wrong. You will get the wrong answer. So if you are feeling okay and confident, like the video, and if not, dislike the video. Thumbs up if you got it, thumbs down if you don't got it. This way, it just tells me which things you want to see more of and do more practice of. And as we do them together, or I give them for homework, whatever happens, I will just continue to record those into little short videos for you guys. All right. Hope this helped. Have a good day.